I'm going to give you all a little bit of a trip through ham radio insanity. I advise you in all of your experiences in ham radio to keep in mind that there's not only great hams out there, there's also a lot of folklore out there, and even good hams are victims to some of it. I'm not perfect, but I try to avoid much of it. I do my best to teach you everything that matches the math, the physics, and the science without having to teach you math, physics, and science. And that's what we're going to do in this class. There are things even that you'll find on the internet where guys profess things that are absolute nonsense. Where they got this idea or that, I have no idea. And then there are things on the internet that are absolutely fantastic. The more I teach you in this class, the more you'll be able to filter that out. I also want to help you not fall into pitfalls, which are either expensive or frustrating or both, so that you won't get discouraged in the hobby. I'm going to share with you right now a screen, which is a screen I'm going to make you familiar with. It's my drawing screen. And on this screen are what looks like a poorly drawn mountain in the sun and a couple of trees. Well, those are supposed to be badly installed antennas. They're not supposed to be badly installed, but I don't draw real good on this. I'm not an artist. It takes me many hours to put together some of the drawings you will see, which are better, but this is just whipped together for an illustration. So to begin with, uh, amateur radio uh, has some simple concepts and some difficult concepts to follow. It is easy to understand that a radio signal set off by, say, point A can go directly to point B, like this line. That one's pretty easy to understand. What isn't easy to understand is that a radio signal can actually leave point B here and make it this way back to point A. This is direct line of sight communications. This one is really strange. It's going the wrong way all the way around the world. I'll explain why that can happen in a minute. I want to tell you, though, about the early days of amateur radio. In the early days of amateur radio, the first ham radio operators basically only produced static. They didn't really know what they were doing, nor did they have the tools today. They use a transmitter called a spark gap transmitter. Spark gap transmitter was just what it sounds like. If any of you have ever heard on AM radio and lightning strike outside and heard the crashes, pretty much it's the same phenomena. If you can make a high enough voltage spark, you can transmit a disturbance across the radio spectrum. Pretty much they had one frequency because they were transmitting them on them all. And they could only work CW. But that's where radio started. I'm not going to go into details of that any more than that. You can research that yourself. But at first, amateur radio, the theory behind amateur radio was really almost mysticism. The early ham radio operators believed there was this hidden part of the atmosphere they called the ether. And the ether was all around. The ether was a magical, mysterious form of of conductor, electrical conductor, which permitted electrons to go between one point and another and caused radio to occur. Today, we know there's no such thing as the ether. It was a good concept. And the fact is, they didn't really know what an electron was. They actually thought these electrons were positive. Boy, they missed the boat, didn't they, guys? Because electrons are negative. And advances in science and mathematics allowed physicists and other scientists to figure out that this was all nonsense. But then they couldn't explain, for example, that sometimes these signals went around the world. They couldn't understand why. So another concept that they began to think, in fact, I think one of them, Tesla, or I think it was Tesla, he believed that those radio signals were actually traveling through the earth underground. Of course, why you need an antenna didn't quite get fully explained. It didn't take long for experimenters to realize that didn't work. You went in a tunnel or underground and the radio didn't get out very far. So that theory went down the tubes. Oh, well, got to come up with something. So how in the world did we come up with an explanation for how radio waves get around the world? Well, line of sight is obvious. And if the earth was flat, it would work great. Because once a radio wave is emitted, it travels forever. Now I get to show you a better drawing. When a radio wave leaves an antenna, let's see if I can blow this up. It starts off and it goes out and out and out and rotates. It just expands outwards forever. Not only does it expand outwards forever, it expands outwards from where it's at and never stops. Now, it may hit something, become neutralized at that point or absorbed, but if there's nothing in the way, I've sent radio signals out when I was a young novice that are about now hitting 50 light years away at solar systems that are, I think, I don't know how many trillion miles, I've forgotten, but I think a light year is like 6 trillion miles. So that must be like 30 trillion miles away. Took the speed of light to get there 50 years. If it's getting there now, I'm not going to be alive to hear the answer if anybody's listening. No. That's easy to understand. All right. But we live on a round planet. Boy, this is not cooperating. See what happens. There we go. Let's make this planet blue. Okay. We live on a round planet. And if we were going to send a radio signal off from our point, oh, by the way, space behind us is black. Yeah, there's stars out there, but I'm going to ignore them. If we send a radio signal out somewhere and it leaves this planet, imagine straight lines, if you will. It's going both ways. It's not only going that way, it's going this way. Basically, off forever, never stops. Obviously, anywhere in this region, you can intercept it on Earth, but the rest of it's gone. But there are some other phenomena that can occur. The atmosphere around our planet, I need another circle, and give myself some I don't know, square. See if you'll cooperate. No, you won't. What did I do? But anyways, the atmosphere around our planet has some interesting components. I probably have a drawing this better. I've done this enough times. I must have a better drawing. Guess not. I'll find you one. Oh, we'll use this and no, we won't. Stay with this for a reason. The atmosphere around the Earth's planet. Oh, okay. Let's make that green. Green. I'm going to now kind of emulate. So this is the Earth with its atmosphere. Now, radio waves can leave one point in the atmosphere and bounce back. There are certain conditions that makes this happen. We call that skip or ionospheric skip. There's a certain level, layer of the atmosphere that can become like a mirror under certain conditions to certain frequencies. I'm going to cover this in the class. Not only that, I often tell people you can talk halfway around the world. Why? Well, because obviously you could turn around and talk the other way, halfway around the world. But in fact, you're not always doing that. Sometimes this skip has what we call multi-hop. So it will get around the world the long way. We call that long path radio or long path skip. Some frequencies will go up into the atmosphere. See if I can bring this down a little. Some frequencies will go up into the atmosphere and they'll follow a lot longer, but they don't really skip off the top of the atmosphere. That occurs from an atmospheric condition called tropospheric ducting. Tropospheric ducting is an actual atmospheric condition. Ionospheric skip is a condition caused because of the sun. When the sun's radiation ionizes a layer of the atmosphere. Another thing I want you to be familiar with is another phenomenon, and that's at some frequencies, instead of just bending, they follow the curvature very closely, very badly drawn here. They follow the curvature of the Earth a little beyond the straight line. That's because the Earth has a magnetic core and it gives us a little extra range over the horizon on most frequencies. That phenomena is called, oh gosh, I just drew a mental blank. I apologize. That's called later and after the break, I'll come up with it. My mind shot, but it does occur, and we take advantage of it. That's called ground wave. Finally came to me. All these things are possible, but there's a lot of explanations for it, and I want you to learn them. The next thing I'm going to point out is that during this class, I'm going to unshare this now. Stop the share. During this class, I'm going to explain these things and why they happen. I'm also going to teach you a little basic electronics. And I call it basic because it is. But they're very powerful tools. If you learn them, you can do a lot more than most ham radio operators know they can do. With just those tools I will teach you, you can do more than just basic radio repair if you apply them, think them through, and take a little effort with it. You have to literally use the tools I give you. You can, well, let me put it to you this way. I usually don't buy a radio for full price. I like multi-thousand-dollar radios that I can't really afford. I'm a almost 70-year-old retiree, and I just can't reach out and spend $10,000 for radio. I would like to say it's because I can't afford it. That's an out and out lie if I said that. The real reason is I'm just too cheap. But I have no problem with going to a ham radio swap and shop, buying some ham's broken radio for $50 that he spent $5,000 on, because it's going to cost him $2,000 to get it fixed, taking it back to my home, putting it down in my electronics lab, opening it up, fixing it, and putting it on the air. I have a funny story to go with that. I have a number of high frequency transceivers now and they're all the same model, because I had one that was bad, as old, and none of the components were available. So I went to a swap and shop and bought another one to part out. When I got that one home, I realized that one was going to be easier to fix than the first one. Only needed minor parts that were readily available. So I fixed it. Then I found people online selling just circuit boards they had stripped from the same model, bought a board with the parts I needed for the one that I originally had. So now I had two working models, and I decided one day at a swap and shop, I saw a third one. And I said, you know what? I'll buy that to have for spare parts for the other two. Got that one home, cost me 29 cents to fix that one. Took a few hours of troubleshooting, but 29 cents of parts later is on the air. I now have about 6 transceivers. I probably spent less than $100 on any one of them. Most of them, $50 is usually my limit. I have one VHF all mode, which means it covers 2 meters, which is 144 megahertz band. It handles AM, FM, sideband, and CW. I bought that for $20 at a swap and shop. The guy that owned it actually begged me to buy it. He didn't want to take it back home. He knew it was broken. I think I got home with it, and that night I had it on the air. I want you to have many of the skills that I have, and you'll actually have them. It's not that hard. The greatest lie in the world, we tell everybody that you have to be a wizard or a super brain or a genius or an engineer or a physicist to fix such things. It's not so. You'll have those skills if you apply yourself. You don't necessarily have to obtain those skills. But if I give you the basic information to those skills, you'll avoid a lot of pitfalls. You'll be able to certainly do simple things for yourself. You also won't buy things that are out and out scams, is the best way I can put it. All right, we're going to stop and all right, it's the Amateur Radio Relay League's license manual. This is the edition, the latest edition with the latest questions and answers. Um, this is for the um, technician class license. This is the fifth edition. Now, if I go back to my library, the next class I teach uses this book. And this book is a general class license book. There is also an extra class license book. Guys, I'm going to cover in this class some things that are covered better in this book, but I will cover them thoroughly enough. You do not need this book for this class. Don't stress yourself out trying to learn both at once unless you really have the time to dedicate to it. Stick with this one. And this book is easy to follow, both editions. Here we go. There are 10 chapters in this book. We'll go over a chapter just about every week. Some chapters I can go through just a little bit faster, and I will cover all the aspects of each chapter throughout the class. I will also, you won't need this book, but I will also be using the ARRL's question and answer book, which gives me all the questions and answers. Of course, I cheat. Let's see if I can get to them. Come on, too much preamble in this stuff. But this is a list of the questions and answers in the book, wherever it is. Is that the question and answer book? Yeah. I suppose there it is. And it has all the questions and answers in the book. I will be going through all of the questions and answers. I will discuss the theory behind all of the questions and answers. I will give you the explanations of why they have these questions and answers. And in one or two cases, I will tell you this is the stupidest question and answer ever written. This is the answer. Why they're asking you this question, I don't have a clue. Neither do a dozen hams that I've consulted with for a couple of them. Even the FCC can't answer them. This is not one that I'm talking about. But I will tell you that you might as well just memorize that one because there's no rhyme, no reason for it. It's a dumb question. I gotta remind you of a couple things that I'm going to constantly be repeating throughout the class. The rules and regulations of the FCC are a part of this class. All of the material, all the questions and answers were written by people at the FCC. They are not ham radio operators. Most of them are lawyers. They write things in legal mumbo jumbo. They call it legalese. I will do my best to interpret legalese for you that apply. And while some good engineers have had input over the years, some of the, just a couple, there's like 3 questions that are really kind of bizarre. Off the top of my head, I don't remember which one. But every time I see them, I know which ones they are. So we're going to go through the book. I'm going to cover all the material. I have tons of external material I will present to you. Today, I'm going to give you just one of those. I'm going to pull this up real quick. I had it open earlier. I'm going to unshare this. Okay, I'm going to give you a piece of equipment that you should have in your shack as a ham radio operator for the rest of your life. I assure you, Every ham radio operator, if I was at my shack, they would have this handy. And this is the um, the ARRL amateur radio um, band chart or frequency chart. And I'm going to share that right now. It looks like this. This chart is your best friend. Every ham radio operator keeps it handy, even extra class hams. It defines where you may operate with what class of license: amateur extra, amateur advanced, amateur general, or novice technician. Defines where you may operate on each band, what frequencies. It defines what modes of operation you may use and what portions of what bands. Like, for example, this section is phone, this is Morse or CW only. Same here. Now, when you look at this chart, you're going to say, wow, technicians don't get very much of this. All this right here, that's not very much in frequencies left over. All the technicians get are roughly from here to here. It's a little bit here and the rest is down here. Let me tell you something. If we take a look at just this one band, the 70 centimeter band, it goes from 420 megahertz to 450 megahertz. That is all of the rest of these together times about 10 in number of frequencies. The reason for that I will explain throughout the class, but it has to do with the fact that at the lower frequencies, a communication has a certain size, takes up so much radio space. In this class, well, define that. It's referred to as bandwidth. The bandwidth for one phone conversation is the same on this frequency or that frequency or any other in the same mode of operation. Some modes, let's take a good example. A TV station would use about 1 megabyte of bandwidth, maybe a little more. Broadcast TV station would take up 10 or 50 with quadraphonic sound and so on. By the way, that's the old style. Today with digital, they run compression. But anyways, those would take up all the radio spectrum, all of this lower spectrum that the generals, advanced, and extras use. But these frequencies down here, they do operate or offer, many of them will skip off the ionosphere. They are worldwide frequencies directly. But today the game has changed a lot. We have other ways of transmitting to each other worldwide. An example of which I'm heavily involved in a repeater project in the state of Michigan. We have linked through internet connections something like 12 different repeaters that are linked from Sandusky, Ohio, all the way up to the Sault Ste. Marie locks in the northern peninsula of Michigan, all the way along the east side of the state. That means I can be driving in my car and work the same group of hams up and down that entire corridor from northeastern Ohio all the way to the top of the upper peninsula of Michigan. That's a pretty long way. What's more, because we have internet links, it's not unusual for guys to link one repeater in Michigan or one repeater in Texas together. And then you're driving along in your car talking to some guy in Texas. I've even talked to guys in Japan, guys in England or other European countries. It's not unusual. And we have today amateur radio satellites. Our satellite technology is getting better and better. We only have one geosynchronous satellite. I'll explain in class what that means. And unfortunately, it doesn't service North America. But the world is advancing and changing, and we're going to get more and more in the future, and there's going to be more. Our technology is advancing. And what I told you about FT8, which hides in the noise level, when that becomes digital audio, you're going to probably see some rule changes that let us use that worldwide um, with any license. I see that day coming. Doing a little predicting for you. Whether I'm going to be around for it, I don't know. I can't predict every change that will come. I will tell you that if in the class, I will send you this file, this PDF file. I advise you to print it on a color printer, have it handy. Every ham keeps one. I frame mine. I keep it framed in each station. And it just comes in handy as can be because nobody remembers everything. In the class, I will teach you patterns to remember the ones you need to know for your test. And so you can pass your test more easily. By the time this class is done, you'll be better familiar with it. And I will explain what it means to have a band such as 17 meters or 2 meters and a frequency such as 18 megahertz or 144 megahertz and what the relationship are between them. When you're done, you'll understand all that'll make common sense. It doesn't today. All right, everybody, that pretty much sums it up for today.